Hello people, so today we'll be solving LeetCode daily question, that is 1514, path with maximum probability, and in this we'll be given an undirected graph of n nodes, 0 indexed, which are represented by an edge list where edges of I is equal to a of a comma b is an undirected edge connecting the nodes a comma b with the probability of success, traversing that edge with the success probability of I. And we'll be given the two nodes, start and end, and we have to find the path in the maximum probability, the path with the maximum probability of success to go, and from start to end, to end and return success probability. And if there is no path from start to end, we have to return 0, and our answer will be accepted if it differs from the correct answer by at most 1 e to the power, basically 10 to the power minus 5. Okay. So for example, this is one of the graph which we are having. So the start node is 0 and the end node is 2. So one of the path which we can follow is direct from 0 to 2, but that is having a probability of 0.2. But if we'll choose this path, that basically, let's consider that the successfully moving from one path, source to destination, is the we have to return the maximum possibility from where our journey will be successful. Okay. So in this case it's just 0.2, so this is one possible answer. In the next case we can choose, we can go from 0 to 1 and then from 1 to 2 with the probability of 0.5 into 0.5, which will be 0.25, which is definitely greater than 0.2. So our answer comes out to be 0.25. Okay, so for this, firstly let's create the graph. So we'll be having list of double basically here, because we don't want any, like while we are, if I'll do this case probability in 20 typecast interval, it will definitely give me errors, and we don't want that. So that's why we are using a double array. Okay, graph that is equal to a new array list, and let's just add empty array list into that. So for int I equal to 0, I less than n, I plus plus graph, graph dot add new array list. Okay, now what we'll be doing is basically, we'll be making the graph. So for in this time I'll be using a standard loop, that is for int I equal to 0, I less than edges dot length y plus plus, and let's have the hue that is equal to edges, uh, edges I0, and oh, let's, okay, so yeah, we are having this won't cause any issue. We can have this as int only, int u int v, and then we'll be having the, okay, let's just push these into the graph. So graph dot get u dot add new double array of v comma success, I guess it's oh, success probability of I. Let's just copy this and paste it here. Let's make it u, and let's here make it v. Okay, so now our graph is ready, and let's return the function call, that is we'll be doing solving this problem by the Dijkstra method. Dijkstra, or I don't know what you people call it. Graph start underscore node and the end underscore node. Okay, so now let's quickly write this one, that is private int Dijkstra. Okay, so we are having a list of double, which is graph. We are having our start node, start, comma int end. Okay, now let's first have n that is equal to graph dot size. Okay, and let's create a probability array double prob, which is equal to a new double of size n, and let's put the start, sorry, probability of start is 1, because obviously we are at starting position, so we are considering that probability as 1. Oh, let's do it 1. Oh, okay, I guess, uh, yeah, okay, yeah, 1.0. Now let's have, for this we need a queue as well, so let's have a queue of again a double array. Let's call it bfs, that is equal to new priority queue. And this we'll be having a custom comparator for the probabilities. So we are having two arrays, so we'll be doing a double dot compare a1 comma b1, and let's just push current into bfs dot add new double of start from start comma with the probability of 1.0. Okay, now while not bfs dot is empty, what we'll be doing is firstly we'll be let's poll the current node, so that will be equal to bfs dot poll, and let's firstly have the current node, so that will be of type int, and let's typecast into int current 0 and double, let's call it current probability prob, that is equal to current 1. Then we'll be checking that if my node is equal to my end node, I'll be returning my current probability. Okay, then what I'll be doing is I'll be traversing in the children for it, so double children array in graph dot get. Again here I have to typecast int oh okay, let's, oh sorry, I don't have typecast because I'm having directly node closing parenthesis missing. Okay, so let's have the child node, basically let's call it nay, short form for neighbor, or you can just call, okay, let's call it child, so that will be equal to, again we need to typecast int children 0 and double child prob, that will be equal to children 1. Then let's calculate the new probability, so that will be equal to child probability into my current probability. Then I'll be checking that if my new probability is greater than my previous, that is node, let's have probability of reaching this child is less, so I'll be updating that probability of child is equal to new probability, and I'll be adding this value to the queue, let's say priority queue, bfs dot add new double of child comma with the new probability. Okay, and at the end, if we do not find any answer, we have to return 0.0, because that's basically means we cannot find any path to reach that particular destination node. Okay, now let's give it a run. Okay, it's taking away. Oh, possible loss conversion from return. Oh, okay, here I should add the return type should be double. Yeah, double. And graph dot get node, any other errors if we are having. Oh yeah, okay, that. Now let's give it a run again. Oh, okay, so it failed on the first test case. It's giving 0.200. It's the expected is okay. Let me just see. Oh, okay, so I found the error because basically we need the maximum probability and not the minimum probability. So here we'll be changing it from B1 to A1. Uh, Sorry, my bad. That was just out of muscle memory. Okay, now let's, yeah, and it gets accepted now. Let's submit it. And works perfectly fine, and it's accepted as well. Okay, so this was for today. Thank you for watching.